Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on quantum physics from June 2022, Paper 4, Variant 2. In this question, we will talk about particulate nature of electromagnetic radiation, or simply we can say particle nature of electromagnetic radiation. We will also talk about wave nature of matter, and we will discuss the evidence for particle nature of EM radiations and wave nature of matter. Then we will talk about de Broglie wavelength, means how we can calculate wavelength of moving alpha particle. Then we will also sketch the graph between wavelength and momentum of a particle. At the end of this lesson, we will also talk about when we pass through a door, why we don't diffract. So we will discuss some interesting point about quantum physics in today's lesson. For question number 8, part A, we need to state one piece of experimental evidence for the particulate nature of electromagnetic radiation. If we look at photoelectric effect is evidence for the particle nature of electromagnetic radiation. Let's try to understand a little bit about photoelectric effect. Imagine that this one is a piece of metal and EM radiations are reaching this metal surface, or simply we can say we shine light on this metal, and we will observe in this case if the energy of the photon of these electromagnetic radiations is greater than work function of the metal. In this case, photoelectrons will be emitted from this metal, and this emission of photoelectrons from the metal only can be explained if we use particle nature of EM radiation. This cannot be explained based on wave nature of EM radiation. So the evidence for particulate nature of electromagnetic radiation is photoelectric effect. So simply for the answer of this question, we can write down photoelectric effect. So photoelectric effect. And this question has only 1 mark. If you have written photoelectric effect, you will get 1 mark. And this is B mark. For the second part, we also need to state one piece of experimental evidence for wave nature of matter. And experimental evidence for wave nature of matter is electron diffraction. Electron diffraction simply means that when we pass electrons, mean fast moving electrons, when we pass them through graphite crystal, they spread out, and this spreading out of electrons can only be explained if electrons behave as wave. So this shows us wave nature of electrons. So the experimental evidence, simply you can write down electron diffraction. Electron diffraction actually takes place due to the size of atomic spacing. If the size of atomic spacing and wavelength of moving electron almost same, then we will observe significant diffraction. So simply you can say electron diffraction, and this question has only 1 mark, that is B mark. For part B1, we need to calculate the de Broglie wavelength of an alpha particle moving at a speed of 6.2 times 10 to 7 meters per second. And de Broglie wavelength is equal to Planck's constant divided by momentum of moving particle, or simply we can say this is equal to h divided by m times v. M is the mass of particle, v is the speed of particle. In this case, our particle is alpha particle, and the mass of alpha particle is equal to 4 times u, mean is equal to 4u, and 1 u is equal to 1.66 times 10 to negative 27 kgs. So simply we need to plug in values now, and we can find out value of lambda. Planck's constant is equal to 6.63 times 10 to negative 34 divided by mass of alpha particle 4 times 1.66 times 10 to negative 27 kgs multiplied with speed of alpha particle, that is equal to 6.2 times 10 to 7 meters per second. If we simply solve this one, our final answer will be equal to 1.6 times 10 to minus 15, or simply you can say 10 to negative 15 meters. So this is value of lambda. So simply you have to use the formula and you can calculate value of lambda. So our final answer answer up to 2SF is 1.6 times 10 to negative 15 meters. This question has 3 marks. The first mark you will get if you have written this formula, and this is C mark. And the second mark you will get if you have calculated value of momentum of alpha particle. Mean if you have entered these values right, you will get another C mark. So this is the second mark. And the last mark is answer mark. If you have got the right answer, you will get 3 marks for this question. For the second part, it is given to us the speed v of the alpha particle in V1 is gradually reduced to 0. On figure 8.1, we need to sketch the variation with v of lambda. We have already discussed in this case that lambda is equal to h over m times v. But in this case, h is constant and mass of particle is also constant. So simply we can replace these two quantities with one constant. So we can say lambda is equal to constant times 1 over v. From here we can write down lambda is inversely proportional to speed of the particle. Or you can say lambda times v is equal to h over m, and this is equal to constant. From here we can find out shape of the graph has to be hyperbola. Means when one quantity is increasing, other one has to decrease, and vice versa is also true. So this is how you can sketch the shape of the graph. So the shape of the graph has to be somewhat like this. So let me draw in a proper way so you can get better idea about this. This is how you can draw in a proper way. So this is shape of this graph, means this is hyperbola. And property of this graph is if you take any point on this curve, for example, if I take this point and I take another point, the product of lambda 1 times v1, it has to be equal to h over m. And at this point, lambda 2 times v2 also has to be equal to h over m, meaning it has to be equal to constant. So it has to stay constant. Then these two quantities are inversely proportional. For part C, we need to suggest an explanation for why people are not observed to diffract when they walk through a doorway. Let's try to understand this one with the help of sound waves. When sound waves they pass through a door, they diffract because we can hear someone talking inside room, even if we are not standing right in front of the door. It simply tells us that sound waves diffract when they pass through a doorway. But people, they do not diffract when they walk through a doorway. So we need to explain reason behind that. Let's try to understand this one with the help of de Broglie wavelength. Matter, you need to understand, also have wave properties. So let's try to find out our wavelength when we walk through a doorway. So we can calculate de Broglie wavelength. Means we can calculate lambda. Lambda is equal to h over m times v. In this case, h is equal to 6.63 times 10 to negative 34. Let's say the mass of a person is 70 kilogram and person is running through the door. So the maximum speed can be 10 meters per second. Now if we solve this one, we can calculate value of lambda. Lambda in this case will be equal to 9.4 times 10 to negative 37 meters. So this is value of de Broglie wavelength. Now let's try to imagine how wide a door can be. Means the gap of the door, or simply you can say width of the door. So we can write down width of the door. And width of the doorway can be about 1 meter. It can be plus minus, greater or smaller. So for simplicity, we will say about 1 meter. Now if we compare lambda with the width of the doorway, you can see in this case lambda is much smaller than the width of the door. So in this case, simply we can say lambda is negligible. So in this case, we will not observe diffraction, because for significant diffraction to be observed, size of the door, means the width of the door, has to be comparable with wavelength of a person. But in this case, lambda is negligible. So that's reason we don't observe people when they walk through the door, they defect. So people don't defect when they walk through a doorway because the lambda is negligible as compared with width of the door. So that is the reason behind. And this question has only 1 mark. If you write down this point, you will get 1 mark. Let me show you the answer, how you can write down your answer. In your answer, simply you can say de Broglie wavelength is negligible compared with width of the doorway. And this question has only 1 mark, B mark. If you have written this one, you will get this mark. That's all for this question. And this is the first question from Module 2022, paper 42. And rest of the questions I will be uploading as soon as possible. See you in next video.